Okay, hello everyone. I'm Xiaogang. In this lesson, we'll briefly go over the document, just 1 or 2 points first. Since this document isn't very easy to understand, it'll be more comfortable for everyone to read after we've demonstrated it. First of all, we know about the local role and the remote role. With these properties, we can determine who is authority over this actor, whether this actor can be replicated, and what its replication mode is. First of all, your character must be authority. This means that the running Unreal Engine instance manages this actor, determining whether it can be replicated, and if you are authority, then your remote role should be simulated or autonomous proxy. Then this engine instance will replicate the actor to the remote connection. We usually go from server to client. We do not go from client to server, but in reality, the client can perceive because it is synchronized over. So it knows what the remote side is like and what its own situation is. So on the server, you see it like this. Then the client actually does a flip. It looks like this, but the client only receives updates. And only the server manages this actor, how to replicate it. And the server does not do it like this, replicating the actor every update. That would be quite band rate, but in reality, it also has it has an update frequency. This update frequency can be adjusted. It is done through this function, light update frequency. That's how it's done. We can see this property. You can see, actually, it is this property called light update frequency. If you want to optimize bandwidth, you can consider these properties, but some things cannot be optimized because when we are doing JS, if the bandwidth is too low, it will cause your skill activation to be very inaccurate. When our JS is mounted on the player status, pay attention to this part. That is if your update interval is too long, it will cause the actor to experience jittering. So we actually interpolate in between. In fact, simulation mainly has 2 types. One is the standard simulation approach. That is to say, the client only needs to update the simulation. And another type is usually used for our player character. We may need to compensate based on our input information, rather than simply extrapolating based on the rate of catching up, because you might still be inputting, constantly pressing keys, constantly pressing the keyboard, right? Then you definitely need to consider player input. So for now, there are these 2 types. Next, let's look at this actor. All these connections, because it's quite complex, because actually when it synchronizes, it establishes such a connection. Should the player controller, if this object wants to handle this and have this capability, then you need an owner. And you need to specify this owner. And this owner can only be specified on the server, correct? That is, as we know, player controller exists on its own client and on the server. So let me show you. Take a look at this diagram. You will see here, you can see this player controller has a PAM, and then they established this which is the first light channel. So it goes with this place, with the one on the server. This player controller and PM are attached together. So the second slot is obviously for the second player. On the client side, they are all this slot to be mounted to. So if you on the client side have some information that needs to correspond with the server, on the client side, you must mount this object to the player controller to make it relevant so that it can then be done. And this connection IE is very important. You can take a look at this description pattern. We are using a client-server model. All clients must connect to this server. And when you connect to the server, it is essentially a connection, but this connection will be further subdivided. That is, it will be divided into several channels. It is a connection. Actually, it's just like when we do that wedge-hunt plugin. We will have a connection. Then after connecting, we will divide which ones are our messages, which messages are for handling hop beats, which ones are handled procedurally, which ones are exposed for the user to do. So the idea here is actually roughly the same. Then after we establish the connection, the player will have a pump, and the owner of this pump is actually associated with our player controller linked together. Only after they are linked together can we determine that the client has the authority to make changes and call remote functions. through this owner. Under normal circumstances, the owner can be null. Generally, there is no owner, because not every actor needs to be linked to communication. Some may just be decorative actors in the scene. They might not move at all. They only need to be loaded in that place. There is simply no need to list them in the channel. As an actor channel, then the ownership of this link is based on actor replication, or when replicating the actor itself, as well as this property synchronization in our RPC remote calls. But we still haven't covered property synchronization and RPC remote calls related aspect. Then there will be a relevance judgment of an actor, that is to say, because it is layered one within another. It is derived layer by layer. It will keep recursing to find the very top layer. So that is to say, if this owner, if you choose, that is only relevant to this owner, then this actor link, here it means, that is to say, its relevance will only be affected by this owner. So only the owner, when synchronizing, will update this property. Otherwise, it does not have this relevance. But this relevance is quite troublesome. We can discuss it in more detail later. And this part, actually this part is the entire situation of this channel's connection. And here there is a recursion. For example, if your character has a backpack, has a warehouse, has a weapon, then it is actually subject to relevance. So it can be attributed to this link for processing. So this is what this part means. Because it will recursively search and then find this link. And only after finding this link can we find the specified client, because we can have all clients execute, but when we need to specify a client, then this actor must have an external attachment, a specific link. Only then can it find the specified client. Okay, so this is some underlying code it uses for searching. Okay, let's stop here for now. Then next, let's talk about some knowledge related to property and behavior synchronization. Let's go over this correlation again. This correlation is actually here. Here, we find the replication section here. Here there will be only relevant to owner and always relevant. Or it's just that, in other words, that is to say, this might be, it might have an owner. So it uses the owner's relevance. Okay, then let's see how it explains it. Why do we need relevance? Because this scene is very large. The player actually only sees a part of it. Most of it we will actually call and will not synchronize it. So if we look at this diagram, so there will be a setting here, a place related to 330 meters. Obviously, it is related and visible here. When this actor exceeds the movement distance, then we consider, after we customize it, it is no longer considered relevant. Then we will stop synchronizing it, so it becomes invisible. Note that here, if this actor is dynamically spawned, when it is no longer relevant, then it will be destroyed on the client. So in this case, the secondary actor is no longer visible to the primary actor, meaning it has exceeded the distance relevance. And here is a relevance argument like this. That is, how do you force it to be considered relevant? We mainly look at this relevance logic. That is, if this actor has checked the always relevant, then we consider it to be relevant to the network connection, or relevant to the player's play control, or relevant to POM, or it is a certain operation, the initiator of the damage sound, we consider it to be relevant. So sometimes this one has a relatively high priority, and then it is owned by someone else, it is owned by someone else. Then we might need to check whether this object it owns has, so if we have no situation, that is, it has no relation to it, it is not owned, that is, it and the owner are also not related, then it becomes unrelated to the network. Then this part is based on some additional related aspects. Then if this part is hidden or not with the main component and is not enabled for empty collision, it is also considered irrelevant. Then here you can adjust the distance, some related knowledge. Then as for the overall definition, it is actually here. If the interviewer asks you about network optimization, you can use this to cover that area of knowledge. Then search for related articles and implement such an optimization. Then how are these functions used? Okay, then we'll just briefly mention this point. Then let's take a look at this priority. Let's finish reading it together. The priority is actually because our resources are limited, so we need to perform load balancing on it. Then whoever has a higher priority, we can synchronize them first. You can see that for actor, its default priority is 1.0. Right, actually here in this place, we find this spot, we find ray, we find replication. There are quite a few things here. Take a look. It should be behind. I'll flip it out. You can see its priority is 3. So this priority of 3 is a particularly high priority. Then you can use some function methods to modify and override the priority. And this part is about determining some input parameters for network priority. It actually involves when you optimize the network. There is a concept of advanced priority awareness. That is what the current player sees and what they are paying attention to. You definitely need to use a high frequency synchronization bandwidth, but if it's not what they're paying attention to, what is invisible or not very significant. So this is an observer, it is an importance analyzer. When we perform optimization, there will be such a concept. Okay, this is a simple priority logic. You can take a look at this calculation. Actually, for now, we just need to understand it briefly. Okay, so here, our concept, it is actually a rather dry concept. Let's just move past this part. Let's move past this part